Question 11 says you have an octagon that's equiangular, so all the angles are equal, and they want to know what the exterior angles on each of the exterior angles, not all of them, but one of them. But we know all shoot, I hate that thing. But all the exterior angles equal 180 degrees, and since it's equiangular, all the angles have to be the same size on the interior, so that means all the angles on the exterior end up going to be the same size. So I can just go 360 degrees for the exterior divided by 8, and that gives you 45 degrees. Okay, so that answers the first part here. Each exterior angle is 45 degrees in an equiangular octagon. Now they want you to extend the question, and the second question was, what would each exterior angle of an n-gon be? Well, we kind of did it already. Instead of using n equals 8, let's use n equals n. And we know the total is 360. And then we know that each one is the same, so we can divide by n. And now we have the exterior angles of any equiangular or regular polygon is 360 divided by n. And so remember earlier I said that's kind of interesting, because how does that relate to the equiangular polygon theorem? And if you forgot that formula, it said this: if you want any angle in an equiangular polygon, so that includes regular polygons, any individual angle, you can do so the equiangular polygon theorem, which if you haven't already written on your theorem sheet, you should have, because I said so, is n minus 2 times 180 divided by n. And we said there's another version of it. There was another version of that, which is 180 minus 360 divided by n. And so if we look at some kind of shape, let's just look at this. I'll just use some kind of quadrilateral. Okay, if we extend it, okay, if we look at that and we say it's equiangular, we can say that the interior angles are in red. Okay, so they're all supposed to be the same. Okay? And if I wanted the exterior angles, I could take any one of those. I'll put them in green. They would be right there. And what do we notice? They look like they are, each set is a linear pair. Each is a linear pair. And so if I want the green one, I can go, the green one would be, the exterior angle is going to be equal to 180 minus the red angle, the interior angle. So 180 minus the interior angle. But it turns out that's what we actually have in here. If you rearrange this, you could also say the red angle is equal to 180 minus the exterior angle. And oh, that's what I have right here. I have that written right here. (180) minus the exterior angle, and if it's regular, it's 360 divided by n. So it turns out that this is the exterior angle on an equal angular polygon subtracted from 180 to give me the interior. So this is right here, and then when you subtract them, you'll get the red one. So the relationship is really that the exterior angle is subtracted from 180 to get the interior angle, and it shows up in the equal angular polygon theorem. So hopefully you're not too confused about that, but that's how example 11 was.